Air Inspect Australia, and he's going to step through. He's their chief pilot, and he'll step through these next few slides. So over to you, Ty.
No worries. Thanks, David, for the introduction. So I'm going to break down Air Inspect's capture processes for aerial site survey and mapping. So you'll see the 5 planning and capture steps on screen. So first step is planning, which we plan with the customer team. We then go in and put down ground control placement with the customer surveyors. We then set up our base station on a known location. Then we launch our drone and fly our pre-planned mission. Then we land and wrap up on site. So then you'll see our 5 steps for processing and output. So we go through and correct our location data, stitch our photos, align our visualization to a coordinate system, validate our position data with the customer surveyor, and then we produce a visualization. Next slide, please, David. So on screen now, you'll see a bit of our pre-planning processes. So first step we do is go to Google Earth. We look over the operation area just to check if there is any obvious hazards, e.g. power lines, power poles, trees, anything that can get in the way, basically. We then obviously go to the weather, because weather, unfortunately, with drones plays a big part in our flights. So we need to check if there's any wind or rain or any other general weather hazards that are going to stop us getting into the air. We then go through our risk assessment and job safety assessments, or JSAs as we call them. We then go over any risks and hazards that are in the operation area, how we can mitigate them and make it obviously safe for us to fly and safe for the public around us as well. We then usually refer to a visual terminal chart, otherwise known as a VTC chart. We do this to check our airspace, check for nearby aerodromes, helipads, no-fly zones, in case we need to get permits from CASA for the flight of the operation. We then have a look at mobile tower maps. We need to check for nearby mobile towers. They can pose a risk during flight, but as long as we know they're there and we can keep away from them, they're not a problem. Next slide, please, Dave. So you'll see some of the additional pre-planning processes on screen. On the left, you'll see our compliance software. This basically is giving us a bit more information on the airspace and the potential risks in the airspace, such as aerodromes, obviously helipads again, and any other emergencies going on, etc. They're usually all included in these maps. On the right, you will see our job safety assessment checklist, or a JSA checklist that we need to perform before every mission. Some of the things that we go over there to check are, obviously we have permission from the landowners, checking for public moving into the operation area, and obviously our ability to stay 30 meters clear of the public are just some of the things that we have to make sure that we're covered. Next slide, please, Dave. So now we go more into the flight planning. On the left, you will see our mapping area was just under 36,500 square meters. Our flight time was approximately 50 minutes. We captured 935 photos, and the flight was flown at 40 meters as to avoid any obstacles, trees, electrical poles, power lines, etc. The GSD, which is the ground sampling distance, was 1.1 centimeter per pixel, and it was flown at 2.3 meters a second. Our white balance was set at cloudy to match the weather. As much as this seems like a small thing, this is where people can go wrong with photogrammetry. Selecting the correct white balance helps a lot with exposure and stitching. Our gimbal angle was set at -60 degrees. Our flight plans can be created in the controller for the missions, either on site or prior, or they can be imported into the controller via a KML file. Next slide, please, David. So this is a little bit more of a continuation of our flight planning. You'll see our overlap for both vertical and horizontal is set at 80%. So this is to ensure there is enough overlap to stitch the images and create the visualization. One thing you do need to pay attention to is the boundary when using a 3D grid for capture. Drones need to fly outside the boundary to capture the data within the boundary. So this can be edited in the planning to minimize the flight outside of the boundary area of the operation to remove any risk of going over main roads or any other hazards that are in your operation area. To complete the capture, we used a DJI Phantom 4 RTK with a DRTK2 base station. GCPs were placed by a surveyor, and the base station was placed on a known point, which you can see in the image on the right. And that is how we end up verifying our data. So issues and challenges with the operation were fairly minimal. Only, I guess, hazard or risk in the area was, pardon me, the Cloundra aerodrome was within 5K of the operation area. So to mitigate that risk, we used spotters so that there's eyes on the drone at all times. We flew low as to not be in the airspace of nearby operating aircraft. And we also made sure we were not located within the arrival and departure runways as well, obviously to stay clear of them. Next slide, please, Dave. So this is where you get to see a bit more of the finished product. So obviously the post-flight processing was done within context capture. The end result was a 21 gigapixel model with over 900 photos. Took about 7 hours processing time. Obviously that is workstation dependent. And the output was a scalable mesh exported in 3SN. And on the right, you will see the AT with all the little dots, which were the positions that the images were taken on the model. And the fact that they are all green tells us that this was a good AT to stitch together, and there was no problems with the model. Thanks for listening, and I'll pass back on to Dave to continue the presentation.